Alright, graphing logs is a lot easier than it seems. Essentially what you need to do is, since all of these logs have a base other than the common base, you need to convert your log function over to an exponential and then graph it, making an XY table. And so here we have y equals the log base 2 of x. So when we convert, so you want to convert to exponential. When we do that, we end up getting that x is equal to 2 to the y. So here we're going to go ahead and create that same x and y table. But in this case, normally we would choose x values and solve for y, but in this case we are going to be choosing your y values and you are going to solve for your x values. So we're doing them reverse. So here I would go ahead and start with -2, -1, 0, 1, 2, and see where you go with there. And so here we have 2 to the y. So this is going to be 2 to the -2. Using your exponential rules, you're going to get 1/4. Next I have 2 to the -1, which is going to give you 1/2. I then have 2 to the 0, which is 1. I have 2 to the first, which is 2, and I have 2 to the second, which is 4. Okay. So with this, we can go in and we can actually graph our graph. So here we're going to look at our values. Graph your whole numbers first. So here when y is 0, x is 1. So in this case, we are right here. When y is 1, x is 2. So that's this right here. When y is 2, x is 4. 1, 2. Okay. Now, to see where we're actually going, you could go one more. We could say what happens when y is 3. Well, this is 2 cubed, which gives me 8. So in this case, when y is 3, x is 8. So 8, 1, 2, 3. And now we go the other way. So at -1, we're at 1/2. And then at 2, we're at 1/4. And so here we are approaching my axis, but never going over. And then here we are continuing on. Okay. And so one of the things that you can see is that this is the exact opposite idea from what my exponential was. So there's a few things to recognize. First, logs cross the x-axis. They approach the y-axis. Okay, and so that's kind of what we have going on here. Now the other thing that we can look at is what your domain is, and in this case my domain is going to go from 0 to positive infinity. So we're going to go from 0 to the positive infinity, and my range is going to go from -infinity to positive infinity. So when we looked at the actual exponential graph, if you refer back over to exponential graphs, you would see that your domain encompasses all real numbers and it's your range that has the start and stop point. Okay, so these are the exact opposite. That is one thing that should start you thinking that exponentials and logs are inverses of each other. Okay, so that is graphing a basic exponential function. Okay. Now the other type of exponential that we can graph is actually more of a translated exponential function. So the first thing I want to do here is I want to rearrange inside my parentheses to fit more with the idea of translations. So here this is my function of the log base 1/3 of -x plus 5. Now in doing so, I can identify the translations that I have. So first and foremost, this plus sign here is going to be my shift in the horizontal direction. The negative sign right here is going to be a reflection in the negative or the horizontal direction. Okay, and so here, if I were to list it out, what this means is that my base function is f of x equals the log of 1/3 of x. From here we have a horizontal shift, and we're going to go left by 5 units, and then we have a horizontal reflection. Which in this case would be over the y-axis. Okay, so those are the things that we definitely have. Now, we can graph this, and we can graph this using the same idea that we did in the last one. So we can rearrange in order to get my exponential function. So again, here, if we're going to rearrange it, we would have that 1/3 y was equal to 5 minus x. So if we actually want to graph this better, we need to get x completely by itself. And so we would do that by subtracting 5 and dividing by the negative. So we end up getting 5 minus my 1/3 to the y is equal to x. So in doing so, I can create that same xy table. So I have an x and I have a y. And just like before, we are going to choose the y values to solve for the x values. So here we can go ahead and do -2, -1, 0, 1, and 2. Now, just like before, we would go ahead and input. So this would be 5 minus, and it would be 1/3 to the -2. And so when you go ahead and solve that, you end up getting -4. At -1, you should come up with 2. At 0, you should come to 4. At 1, you should come to about 4.67. And at 2, you would get roughly 4.8. So one of the things that you can see here between, let me change colors, between these two values, here we are approaching x equaling 5. Okay, so that's kind of where we are approaching. And so now we can take these values and we can go in and we can graph them. So first and foremost, let's start with the point 0,4. So we can come up here and we have 0 or 4 zeros, so right here. We then would have -1 and 2. So when we go over x2, we're down at -1. When x is -4, we're down at -2. We have when x is 4.67, we have y is 1, so we're at almost 5, and we're up here at 1. And then same thing, when y is 2, we're again almost 5. And so we actually have going on here is that my graph here is getting very, very close here to being 5, and then it is scrolling down here at this point and keep on going. Okay. Now, one of the things that you can notice is that we did go through our horizontal. So if you look at it at having just 1/3 x, the first thing that would happen is that we would have my graph going through this point right here at 0, 1. And so what would happen with this is that we would get incredibly close here to my axis, and we would continue on going down in this kind of direction. So if this is my basic graph, what happened is we took this point and we first shifted it. So from here we went 1, 2, 3, 4, 5, brought it over here, and then we reflected it. So here's my y-axis, which is how the point ends up over here at 4. Okay. So recognizing how your translation works is going to be a really good idea for making sure that you're graphing it on the right in the right places. Now the last thing that you can look at is that it's going to have a domain, and in this case my domain is going to go from -infinity up to 5, and my range is still going to be all real numbers. Okay. So that is everything you need to get going in looking at graphing logarithmic functions. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I'll see you next time.